One of the questions on your pretest was how to say this. How do you say this?
X squared.
X squared. How do you say this one?
X cubed.
X cubed. And then what if we get to something like this? Do you know how to say that one?
X quadruple.
Ooh, X4, no.
It's plus.
So this is important because I'm going to be a real butt about the notation and saying it correctly. If we're going to say this one, we say the words to the in the middle. So this would be x to the fourth power. Okay, so if I wanted to say in general, this one that's written on your paper, how would you say this one?
A to the n power.
A to the n power is how you would pronounce that. That is A to the n power. So whatever numbers are there for A and n is what you say instead of A and n, obviously. But A to the n power is how you say it. I'm going to be a butt about saying it correctly because it sounds better than saying x4 to say x to the fourth power. Okay, that is actually correct, the correct way to say it. Now, there's a few definitions I'm going to use today that we need to talk about that you may not have heard before. The first one is the big number. The number that is being multiplied here is called the base. Okay, that is called the base. It's the big number, it's the bottom number, however you want to remember that, but it's called the base. The base is the number or letter being multiplied. The number or letter being multiplied. Because exponents are just a shorthand for multiplication. When the people who did the notations for algebra realized that we needed to write multiplication over and over and over again, and they got tired of writing stuff like this, x times x times x times x. They're like, let's make a shorthand for this because we're too lazy to write that out that many times. So they called these exponents. X to the fourth power means that I'm multiplying x by itself 4 times. So I would be multiplying a by itself n times. Now the number of times that I am multiplying it is called the exponent. So the number that's up there, it's floating up at the top. Some people call them the little floaty boys. This is called an exponent. The exponent is written smaller on the shoulder floating of the base. It shouldn't be the same size as the base. It really should be a superscript, like actually up there. It is how many times the base is multiplied. Okay. One of the biggest common mistakes I see with exponents is seeing something like this and saying that the answer is 10. That's not correct. What did they do wrong if they were saying that answer to 5 squared is 10?
They multiplied by 2 instead of by 5.
Yeah, 5 squared means this is 5 times 5 happening twice, not 5 times 2, but 5 times 5, which is 25. So make sure you don't accidentally fall for that trick. When you have numbers, you actually have to multiply them out. Don't multiply base times exponent. Actually use exponent rules. Okay, now I kind of lied earlier when I said we haven't used exponents really all year. We actually have. You just didn't realize it. Because just like there's an invisible coefficient or invisible big number in front of letters, there's actually invisible exponents. And it's the same thing. So what do you guys think the invisible exponent is? 1. So any letter that has no exponent technically has an exponent of 1. We're just too lazy to write it. It's not necessary to write the exponent of 1. Okay, that's super important to know for later. We have to know that any variable or number that's just chilling by itself has an exponent of 1. Now it's also important to be able to say and identify parts of an exponential term. Okay, how would I say this first term right here? 5 cubed, or I could say 5 to the third power. Cool. That works as well. What is the base here? 5. What is the exponent? 3. And what is the expanded form? If I weren't using the shorthand of exponents, how many times do I have to multiply 5? This would be 5 times 5 times 5. Now, since this is a straight up number, it would be best if we actually also talked about its evaluated form. What is 5 cubed? Don't say 15.
You gotta add.
Ooh. 5 times 5.
25.
Times 5.
125.
125. Okay, if you don't know how to do that, you go to your calculator, and on your calculator, you either type the following. You type 5 times 5 times 5, because it's 5 3 times, or you use the exponents to do it. The up caret is underneath the clear button. It literally looks like a little arrow. Okay, you're going to press 5, then a little up caret, and it puts your cursor up there in exponent world. And what number do I put up there? 3. And it would give me 125. So if you have numbers, you're going to want to multiply them out. Don't accidentally do the trick with 3 times 5. It's not 3 times 5. It's 5 times 5 times 5. Okay? Just a little tidbit. But very good. That is the expanded form. 5 times 5 times 5. Now the second one. How do you say that?
5. X to the power 5th.
X to the 5th power.
Oh.
X to the power of 5. All fine. As long as there were 2 of those in there, I'm fine. What's the base here? What's the exponent? And what's the expanded form? That was a lot of x's, but yes, there should have been 5. 5x is x times x times x times x times x. Cool. All that exponents are is a shorthand for multiplication because we are too lazy to write it all the way out. Can I give you guys the third one to try on your own?
Yeah.
I want you to practice saying it to yourself and then tell me the base exponent and write the expanded form. Ready, set, go. How would you say that one?
Negative 3 to the third power.
Negative 3 to the third power. What's the base?
Negative 3.
What's the exponent?
3.
3. Now the expanded form, there's 2 ways you could write it. There's my preferred way to write it is with the parentheses. Because parentheses smushed next to each other means that I'm multiplying. So this is my preferred way to write this. But if you wrote negative 3 times negative 3 times negative 3, that's technically the right one. But that's like a lot of little like symbols happening. I like the parentheses version better, but they're still correct. Yeah. If they give you parentheses, I would use the parentheses. It just makes sense. Now this last one's kind of confusing. How would you say the last one? 2x to the power of 5. So when I say this to myself, like when I just do this by myself, my hands go like this. What are they doing? They're making parentheses whenever I say 2x to the 5th. Because it's not 2x to the 5th, it's 2x to the 5th. The parentheses are important. Yeah, because this is important because this exponent isn't just touching the x. What is it actually touching? The parentheses. So everything inside that parentheses should have an exponent of 5. Or basically this entire thing is what I'm raising to the 5th power. It's important to know that this is different from this one. Do y'all see a difference? Exponents only affect the thing it's touching. Here it's touching the parentheses. And in this other one it's touching just the variable x. Doesn't affect the 2 at all. There's a difference there. So since we're going to do not this version, what is the base?
2x.
What is the exponent? So the expanded form would be writing 2x times 2x times 2x times 2x times 2x. Woo! Yeah, 5 times. It's a good thing we have the shorthand, right? Because this would be real annoying to write out every time. You're like, it's fine. Okay, when we're doing the properties on the inside of these notes, if you are like, Miss Quigley, I really don't understand what you mean by these properties, a lot of times writing out the expanded form for each of the properties we're going to go over will really help you understand the property and or simplify the expression. So if you're like, I don't get it, go back to this expanded form idea because a lot of it will make sense. And I'll show y'all some of the expanded form ideas while we're doing the properties. But I like the shortcuts of the properties much, much better. Are you ready to move to the inside? Cool. We are not filling out this entire notes today because that is overwhelming. We're only going to do the first 3 rows of properties. The first set of exponent rules, I lovingly call them my mad spam rules. Those aren't official titles of anything. This school uses MadSpam, so if you talk to your Algebra 2 teacher about MadSpam, they're going to know what you're talking about. But if you go to a different school, they may or may not know the acronym MadSpam, so it's hopefully a time for you to know it. It's taken out of an SAT prep book, so if you go to SAT preps, they do use MadSpam, that's why we use it. It is an acronym that you will find on the back wall in blue. You'll also find it on your green piece of paper. It's on the picture side. It's number 17. MadSpam is there for you. But not only is MadSpam there for you, the actual names of these properties is on the other side of your formula chart. Numbers 3, 4, and 5 are the straight up properties that we're going to be using today. So you don't technically have to memorize these things because you have a formula, but they're easy enough to memorize, might as well. Okay? We're going to start all with the first row, talking about the product of powers property. It is the first 2 letters of MadSpam. Watch up on the board what I'm going to do with my highlighter. MadSpam is 3 of the 6 exponent rules. The first one is right there. That you can't really see what I'm doing because that's a highlighter and I need a pen. What it tells me is that if I am multiplying bases that are exactly the same, what am I going to do with the exponents? Add them. If I'm multiplying the bases, I add the exponents. That's exactly what this property is going to say on your formula chart. The property says that if you have a to the m power multiplied by a to the n power, that should be equal to a to the m plus n. Let's go ahead and fill that one in. Straight off your formula chart should be number 3. The third formula, a to the m multiplied by a to the n is equal to a to the m plus n. It's the MA part of MadSpam because we're multiplying those bases. We add the exponents. This is called the product of powers property. The formula is a little weird to look at, but literally all it's saying is that if you multiply the bases, you add the exponents. Exponent rules are different from regular number rules. Okay, here's what the work would look like to solve or simplify, simplify some of these problems. Okay, I have x squared multiplied by x to the 6th power. Those bases are exactly the same, so all I have to do to multiply them is add their exponents together. I do want to see this step, so go ahead and write this down because this is what your homework should look like. It'll have a problem. I want to see the intermediate step, and then we simplify. 2 plus 6 is 8. So x squared times x to the 6th power is simplified to x to the 8th power. That's it. That's using the product of powers property to simplify this expression. Now we look at the second one, it's just as easy. But what have they not told us about the second problem?
The exponent.
The exponent of which one?
The first.
Yeah, but like it's invisible, so what number is it? 1. There's actually a 1 chilling right here. Boop. And if it makes it feel better to see it, go ahead and anytime you don't have an exponent showing, go ahead and write it in. And since we're multiplying, MadSpam tells me that I'm going to add these exponents together. 1 plus 5. That would be y equal to 6. So y times y to the 5th power is equal to y to the 6th power. Easy enough, right? The only way I can make it more complicated is if I add multiple letters at the same time and or good old-fashioned numbers, like this third one over here. You treat numbers like you've always treated numbers. So we're going to take -2 and 7, and we're going to multiply them like they're regular good old-fashioned numbers because they are. What is -2 times 7? Okay, cool. -14. Then we're going to look at the A's because those bases match. Those are the ones I'm going to multiply, add together. So this would be a to the 2 plus 3 power. Where did I get the 2 and 3 from?
The exponent.
Yeah, the exponents from the first and second parentheses, since they're both from the a variable. Those match. Do y'all see what I'm doing here? So a squared and a to the 3rd power, those are both a bases, so their exponents can go together. Which means, what am I going to do with the b's? Add them, but they're invisible. They don't have an exponent showing.
It's 1.
It's 1. So there's a 1 here and a 1 there. 1 plus 1, which would be 2. Okay, so then I can just simplify this down to the final step. Negative 14 a to the 2 plus 3, which is 5, times b to the 1 plus 1, which is 2. And that's the simplified version. That's about as hard as it can get. Did I lose anybody on that? Do we have a question? Yeah, what's up?
What?
This was next to that B.
Where? In purple? 1 plus 1? Because those are the exponents. I'm going to have you guys try this last one, the fourth one, on your own. Go ahead and give it a shot. So these bases are the same. So literally all we have to do is add them together. So this would be r to the 12 plus a negative 10, which, yes, when I add 12 and negative 10, I would get 2. R squared would be our final simplified.
12 minus 10.
That 12 minus 10 and 12 plus negative 10 are exactly the same thing. Very cool. That's our first rule. If we're multiplying the bases, we add the exponent. The MA part of mad spam. The second rule that we're going to talk about today is the DS. This is called the quotient of powers property, and I did the highlighter thing again. If we divide, we subtract. So this rule says that if you have a to the m divided by a to the n, again, the bases have to be the same for this to work. All we have to do is subtract instead of add. Now notice they are subtracting top minus bottom. That's important, but it makes sense to go top minus bottom, so I don't think you would choose any other way. Always top minus bottom. That is number 4 on your formula chart, the quotient of powers property. So if we're going to do a couple example problems for this one, we would make sure that the bases match, x and x, and instead of adding, since I'm dividing, I would subtract. This would be x to the 5 minus 2, and x 5 minus 2 is x to the 3rd power, or x cubed. That's it. Simple. The second one is y squared divided by y, but this is just like y to the 1st power. So we would continue to do our power or quotient of powers property, y to the 2 minus 1. 2 minus 1 is 1, so I could write y to the 1st power or just a regular y. Both are fine for me. I would prefer this one. And answer choices on tests will be just y and not y to the 1st power. But if you write down y to the 1st power, I won't count it wrong for you. Now, I kind of blew through those 2 examples. Does anybody have a question? Are we ready for the challenge ones? Sure, tentatively, yes. Okay. Now, the only thing that can make this harder is if I add numbers and different types of letters. But just like with multiplication, you match up the letters. Same thing with the division problems. You treat the regular numbers like you've always treated regular numbers. This is 27 divided by 9, which is 3. Treat regular numbers like you've always treated regular numbers, but treat exponents like you just learned to treat exponents. The x's are on top of each other, so they match. This would be x to the 5 minus 2. There's also y's on top and bottom. So I'm going to use the quotient rule there as well. This would be y to the 4 minus 3. Then I just simplify it down. This would be 3 x to the 3rd power, y to the 1st power, or just a y. You take it piece by piece. Good old-fashioned numbers, letters that match, piece by piece. X's and Y's, or A's and B's. Once you get this one copied down, I am going to give you a chance to try that last example on the quotient rule on your own. So give it a shot. See what you can do. Don't panic. You can do it. Seeing lots of good things. I think I'm going to cut off your thinking, but I think most people have at least something down. We're going to treat regular numbers like we've always treated regular numbers. 18 divided by 2 is 9.
Oh, wait,
9. Yeah, you're right. And then we have these h's that match. So this is going to be h to the 4 minus 2. That's top minus bottom. And then I have a j, but I don't have any other j's, so I'm just going to let it be there. Is that what y'all chose to do? Sweet. Great choices. And then we just combine it down, simplify. This is 9h to the second power j. Is that what y'all got?
Yep.
Oh, I'm so happy. Yay. So I'm going to take a second now off the screen here, and I'm going to show you what this looks like using some tiles. This is like the expanded form that might be more helpful for you to get these skills right. So the last rule is called the power of a power property. Okay. It is the PM part of mad spam. The PM technically stands for power of a power. Drag it over to the M. So power of a power, we're going to multiply.
You did the highlighter thing.
I know, I did the highlighter thing again. Power of a power, but a lot of my students from last year said, well, Miss Quigley, all I remember is that P stands for lots of parentheses. If there's lots of parentheses, you probably are going to use the power of a power rule. And I was like, okay, that's fine. Technically, it stands for power of a power. We're going to multiply. What this looks like is if we have, standing right in front of it, if we have a base and a power, and then we raise that to another power. Power to a power. We're going to multiply those two powers together. That's the PM part of mad spam. Now, here's the thing. This is not distribution, but it kind of looks like distribution. Okay, if you go anywhere and you ever tell another math teacher, I told you this is distribution, they're going to be super mad at me. It is not distribution, but it looks like it. Because what happens is it looks like we're going to take this n power and multiply it inside the parentheses. And technically we are, but it's not called distribution because it's exponent to exponent distribution. I'm using air quotes distribution. Okay, it's not really distribution, but it looks like it. So you can think of it that way if it helps you remember that exponent has to multiply to every single exponent in the parentheses. If there's 1, there's only 1. But if there's 3 or 4, every single exponent gets multiplied. Okay? This is my favorite because it gets kind of crazy. If we look at some of the early examples, they're pretty easy. X squared raised to the 4th power. All that means is that I'm going to take x squared and multiply it by 4. So this is x to the 2 times 4, which is just x to the 8th. Now this is because, I'm going to switch over to the tiles here for a second. So let's try this other one. We have y cubed raised to the 2nd power. So again, I'm just going to multiply exponent to exponent like distribution, but it's not distribution. This is y to the 3 times 2, or y to the 6th power. Pretty easy, right? No.
Yeah.
Here's my favorite problem on all of these notes.
Yeah.
Because this one really looks like distribution even though it's not. It's not distribution. It's not, but it looks like it. Air quote distribution. Okay? This is 5x squared yz cubed all raised to the 5th power. What?
Oh, wait.
I know. But we have a power to a power. We have some stuff inside here and we have it raised to another power, so we have to employ this rule, power to a power. Before you do anything on power to a power, I need you to make sure that every exponent is showing. Now what I mean by that is the exponent of z is showing. What's the exponent of z?
3.
What's the exponent of y?
1.
1. It's not showing, so I'm going to write it in because I think that's important. Okay. Boop, there it is. What's the exponent of x? What's the exponent of 5?
1.
Oh, snap, that's awesome. How did you know the exponent of 5 was 1?
It doesn't have.
Because it doesn't have a freaking number.
It doesn't have a number back here. A lot of people think that it's 2. Why do you think they're mistaken and think that it's 2?
They think it's 5x.
Remember, the exponents only affect the thing that's it's touching. This 2 is only touching the x. It's not touching the 5, so there's actually an exponent of 1 next to that 5. Very good. Rock stars. Been teaching for 5 years. No one's ever answered that question correctly, so I'm really proud. Okay? So when I do the power of a power rule, it's going to look something like this. And that's when it kind of looks like distribution, right? Kind of.
Even though it's not.
It's not distribution. But what this means is that I'm going to be multiplying that power of 5 to every single exponent that's inside. This would be 5 to the 1 times 5, x to the 2 times 5, y to the 1 times 5, and z to the 3 times 5.
Oh gosh.
That's a lot of times 5s. But writing it out like this guarantees that I don't accidentally do this wrong. Because a lot of people would accidentally multiply just 5 times 5 and make it 25, but it's not. It is 5 to the 1 times 5 power. So if we keep simplifying this down, there'd be 5 to the 5th power,
X to the 10th power.
x to the 10,
Y to the 5th power.
y to the 5th,
And Z to the 15th.
and z to the 15th. Now this is an okay answer, but technically it's not all the way correct either. Because I have some good old-fashioned numbers in there that I can simplify.
Ooh.
You see this right here? 5 to the 5th power. Don't say 25. What is it?
Oh.
Ooh.
No. Oh, I know this.
It's
one.
like over 3,000.
Oh, dang.
Someone help me out. I'd already showed you in a calculator how to do this. Tell me what 5 to the 5th power is.
3,125.
Wait, huh?
3,125. 5 times 5 times 5 times 5 times 5. That's a lot of times 5. You're just... Oh, right. Okay, yeah, you're right.
See, I said 125.
Miss, that's too much.
You're right. Exponents get really big really fast. But that's okay.
Dang, no, Mom.
So if today when you're doing your homework you were to stop here, I'd still count that right. But technically, if you have good old-fashioned numbers raised to powers like 5 times 5 or 3 to the 8th power, you actually need to multiply them out. Just no. Yeah, you should. You should multiply them out. Letters stay with exponents. Numbers can be multiplied out.
Hold up. Wait, oh, wait.
Okay?
Miss, what's there after the X?
10.
What's there?
X to the 10th power, is that what you're looking at?
No, like, what you boxed in?
Y to the 5th.
X to the 10th, y to the 5th, z to the 15th.
That's a star.
So this very last one is two kind of pieces put together. If you notice, we're going to have power to a power rule because we have 7x cubed all raised to the 2nd power, y to the 8th all raised to the 1/2 power. Okay, not a big deal. Let's make sure we can see all the exponents before we begin the power of a power rule. What's the exponent of 7? 1. Very good. Yep. And now the exponent of x is 3, the exponent of y is 8. We can see all of them. And now we use the power of a power rule to not do real distribution, even though it looks like it. This is 7 to the 1 times 2, x to the 3 times 2, and y to the 8 times 1/2, or 0.5. So what is 1 times 2? 7 to the 2nd power, x to the 6th power, y to the 4th. Am I finished?
No, you got that Y.
I have what?
Sorry, these 7.
I have the 7. 7 squared is a good, just straight up numbers. There's no letter involved, right? So what is 7 squared? Don't say 14. 40. Where is it? 49. 49 is a perfect square. That might be one we need to have memorized. By the way, if you don't have your perfect squares memorized up to 10 or 12, probably should. Cubes, maybe 2 would be helpful, but whatever, squares. This is the correct simplified version, but again, if you stopped here, I would give you credit for it right now. Technically, if you have numbers, they should be multiplied out. Okay. The reason I'm making such a big deal about that invisible one is because on the last 4 star tests, there have been a question about this, that instead of this answer, 3125 with the correct exponents, they've had that as an answer choice, and they've also had 25. Because they trick people all the time that end up doing 5 times 5. That's not it. This is 5 times the exponent, which means it's 5 raised to the 5th power. So don't fall for that trick. They'll get you. They do it every year. Don't fall for it.
We're done now.
We are going to be done with notes for today. So before you start moving all the way around, listen. These notes need to come back next class because we have not finished all of the rules. There are 3 more rules we're going to have to go over that don't fall under the mad spam category that we will talk about next class. Okay, we're gonna practice only mad spam rules today. You can probably want to keep your notes out for the activity we're about to do, but behind your notes is your homework that needs to come back next class finished. I know there's a lot on there, but it should be like real quick to get these problems done. The more you do, the easier it becomes to do these kinds of problems.
These hard.